In this lesson, we will discuss aircraft rivets, the different types of rivets, and the rivet numbering system. Additional information on this topic can be found in pages 554 through 564 in the General Aviation Maintenance Technician's Handbook and in Chapter 7 of Advisory Circular 4313, the Acceptable Methods, Techniques, and Practices of Aircraft Inspection and Repair. The rivet shank should be slightly smaller than the hole through the material being joined. As the shop head is formed, the rivet shank will expand to fill the hole. Before the rivet is set, its shank should extend beyond the material being joined a distance equal to 1.5 times the diameter of the shank. Once the shop head is formed, it should be 1.5 times in diameter, the diameter of the shank, and the thickness of the shop head should be 1/2 the diameter of the shank. For quiz purposes, you will want to memorize the end numbers for these rivet head shapes, as well as the name of the head shape. You should memorize these rivet alloy numbers and corresponding 1 or 2 letter alloy identifiers, and the rivet head markings they correspond to for quiz purposes. Now we can see how the part number for a rivet fully describes the rivet. In the part number AN470AD4-5, the AN gives us the standards the rivet was built to. The 470 informs us of the shape of the rivet head. The AD informs us of what alloy the rivet was made of and what heat treatments it has undergone. And the 4-5 tells us the diameter and length of the rivet shank. Friction lock rivets are not used in structural applications because of the possibility of the rivet stem coming free. When a rivet puller applies a pulling force to the rivet stem, it pulls the expanding section up into the rivet shell, causing it to expand and fill the hole. The header then forms the shop head. After a certain point, the pulling force will cause the stem to break off, and the rivet is then set. The mechanical locking rivet works similarly to a friction lock rivet, except that as the rivet is set, a locking collar is crushed into a locking groove to securely hold the stem in place.